Hello everyone, I'm Cole from Make Channel. Today's topic is more serious and very important in X-ray diffractions. I intensity determination of X-ray peak. That is very useful for better analysis of a certain material. So first of all, let me draw some diagram. Y-axis is intensity. Intensity means this has no units. So it just shows relative peak strength. X-axis is 2 theta. Theta means diffraction angle. This is very simple. We know these 2 theta can be determined by Bragg's law, as I explained before. N lambda to the sine theta, right? Now, how can we determine y value, the peak value? There are several factors. Some textbooks say like that it should be 7 different factors, 5 different factors, but here I want to describe only 5 different the factors affecting y value intensity. In that kind of case, and then I want to give you some restriction. It's not for polycrystalline material after deformations, but for some powder material, and that should be crystalline. Two choice. These indicate the crystalline powders. Yeah, sometimes it's hard to determine the X-ray differential peaks because there are some powder is moving out by the external force. But anyway, for theoretical issue, crystalline powder, this means random orientation. So is to understand what kind of crystalline structures affects intensity, the y value, y-axis value. So I'm going to use the powder crystalline material. 자, first one. Yeah, structure factor. If you are a student, one university or college, you're going to attend the X-ray diffraction class. Here, normal X-ray diffraction when you just be some juniors and you can take part in this class, and before that and then sophomore, you must attend crystal structure and defect. But here and then, I don't need to explain the crystal structure, but nevertheless, you can understand. I will try to show you crystal structure, general concept in an easy way. So, structural factor, this one is first one. So, from the initial S, F, normally and then crystal structure, we use Miller index H, K, L. The second factor is, yes, polarization factor. Polarization factor. Okay, simply say, and then we can say P, F, I can give some theta value right here. That must be region. Third one, from the Bragg-Brentano X-ray method, we must consider Lorentz factors. L, F. I want to give theta. Why I just give theta? Yes, polarization factor, Lorentz factor, largely affected by Bragg law, diffraction. So I can give some kind of small subscript as a theta. Number 4, multiplicity factor. Do you know some families? And then family means and then containing several elements from the individual index for the plane and direction. So once we just give some specific note 1, 1, 1, and how many 1 are inside? Yes, anyway, this one is M, F. This also associates with crystal structures. So I can give H, K, L. So 1 and then 4, two things associated with crystal structure. Even if you don't know any concept of the crystal structure, you can easily follow me. 자, last factors, temperature factor. NTF. Normally, 0 degree of Celsius, 0 degree of the Kelvin and very low temperature. And then we know, and then all the material just half. There's no thermal vibration anymore. As temperature increase and then some lattice structure shows some kind of vibration behavior. This vibration also affects some change in intensity value in X-ray diffraction. That's why we need to consider temperature factors affecting intensity. So you can say by thermal, this one. And then you ask the question and then there are 5 different factors. The which one is most dominant? Yes, I can say the result is very simple. Structure factor. Structure factor is the really primary one. And then after that, we can consider multiplicity factors, the secondary. And then third tier will be normally, and then the polarization Lorentz factors is associated with the theta angle, two theta angle, Bragg angle. So we just combine together L, P, F. F means and that Lorentz polarization factors. So L, P, F, theta. The third one, the small issue coming from temperature factor. There are sequence. That's why if you have some kind of critical mistake for the calculation of LPF, RTF, it doesn't matter. This influence is so small. That's why you need to focus on severely structure factor. How can I determine the structure factor? This is the most important. What about the structure factors, and still you cannot get a good concept about this one and then. So I will introduce scattering. By or matter. metal or material. Same case. 자, small units in the matters is electron. In the case of the X-ray diffraction, there are maybe so small the particles like a cork, and this is very useful in physics. But here in X-ray, we just think about electron is really basic one. And then we can consider atom. Atom, they are clusters and a elliptic plane. This one is crystal structure, unit cell. Right? So that's why there are some kind of sequence like electron as a tiny matters, atoms, and then after this, the cluster of atom can be the unit cell. The electron, during X-ray diffraction, it generates polarization. The behavior. So we can calculate the polarization factor coming from electron. Here is positive at the center of atoms, and there must be shells and electron right here. The X-ray. X-ray is just kind of electromagnetic wave, and then it's coming to the electron, and then it should be diffracted in this way. So this angle is 2 theta, diffraction angle. This is a Bragg angle. That's why, and then here's, and then second factors I described before, polarization factor is coming from electron itself. And then atom. Atom, as you know, just atom, one itself. Unit cell. I will give you very simple unit cell models. So we can give some cubic structures. Yeah. Cubic will be defined as some geometrical shape having same axis, right? And then each axis have the 90-degree relationship between them. So at the corner, we can put this atom right here. And then another here, back side, and I can give 4. And the front side, 1, 2, 3, 4. But okay, there is some simple question. How many atoms in this cell? And then you can count it 8. No. So each corners have the 1 atom, but it divided by 8. So that's why 8 multiplied by 1/8. That's why it becomes 1. So total number of atoms in this unit cell is 1. Simply we can say this is simple cubic. This also changes significantly by the scattering. What about then? Structure factors. So we can take our structure factor HKL. Here I want to introduce something and then probabilities. This one, this scientist and then from France, that's why his exact name is probabilities. But sometimes we just say probabilities, but doesn't matter, it makes sense. But we acknowledge his nationalities, we must say probabilities. Probabilities have the 7 different crystallographic system. Crystal system. On the 7 different system, it has 14 crystal structure. This is very, very important. I remember that so many students, professor, I want to join global company in South Korea after graduation. So such as POSCO, Hyundai Steel, there are many companies in South Korea, so famous. But I can say that there must be the 20 importance, the knowledge in material science engineering. One of them is probabilities. So I will introduce it later. Today I'm going to talk about brief introduction of some kind of factors affecting intensity value of diffraction peak. Previous case and I explained what kind of things will be changing x-axis in diffraction peak. Yes, this one is regular to theta value. I know the from here and then someone feel more some kind of difficult in the calculating following of this class. But anyway, I will explain step by step. I hope really can enjoy our topic. Okay, let's go to the days. I will find you with better contents about intensity determination in the next video clip.